I'm going to find natural frequencies of a 2 degrees of freedom system using ANSYS Workbench. So let's see. At first, let's review our 2 degrees of freedom system. So what you're gonna do is this system, the 2 degrees of freedom system. But I'm gonna assume that, assuming that the masses and K's are the same, stiffnesses, then natural frequencies of this system is going to be equal to, first one is going to be 1.618 times of radical Km, K divided by M. The second one is going to be, let me see, the second one is going to be, hand calculation. First one is going to be 1.618 times of radical Km. The second one is going to be 0.6181 times of radical Km. Okay, so for 2 degrees of freedom system, we're going to confirm this with Workbench. Okay, so to do this, let's open Workbench, go model analysis, and then for material, I'm going to leave it steel. So let's go geometry. Gonna use design modeler. So let's see. We're gonna do it using Workbench, and then we're gonna do it using hand and show that they're gonna match, hopefully. Okay, so let's go down, drag this down. So I'm gonna model the masses using two spheres. All right, so let's go down. All right, so first mass, I'm gonna consider like 1 meter sphere. So for this one, like this, and all right, so let's do this. Okay, let me change. To make the sphere, I'm gonna make like a half a circle and then revolve it. But let me change the radius, make it right. Okay, right now the radius is, well, it's let's make it 0.5. And then I'm gonna do another line. Draw a line. I'm gonna actually do it like this. Maybe we can do both at the same time, both circles. Okay, let me do both circles at the same time and then revolve it. Okay, so let's say this one is gonna sit here. Alright, so let me dimension this right. This must be 0.52. Right now it's 0.8, so 0.5. Oh, this is diameter, I'm sorry. So we have to change the diameter to 1. Okay, so these two circles are both the same. Let me do this line. Alright, now I'm going to trim away. The parts I don't need. So for doing that, I'm going to trim away this top part, this part, this part, this part. Yeah, all right. So now we're gonna revolve it. Okay, so revolve these two guys about axes. For axes, I'm gonna pick this guy. We're gonna have now 2 spheres. Okay, so these two guys are 2 parts, 2 bodies, but I need to convert them into 1 body. I'm sorry, 1 part. So right click, form a new part. Now we have 1 body. So now let's go. We have, 1 part, 2 bodies. So go out, go to modeling, and then do the add the springs. All right, so let's go there and see what we got. You know, as we saw from theory, that first natural frequency is 1.618 times the radical km, and then the second one, 0.618 times of radical km. I want to have nice numbers, so I want to have k divided by mb like 100, so 10 comes out. So let's see. To define the k's, to define the k's, I'm gonna have. Let's see. The math is 4 110. So I'm gonna have this stiffnesses to be 100 times of this. So let me write this down somewhere. Let me write it down here. So 100 times of 4110.3. So I'm going to use this as my k. So radical k divided by m is going to come out 100. Okay. So when I'm making my springs. So look, for springs, I'm going to connect first this body to this body. To do that, you go for springs, body to body. Connect those two bodies. So first come here, the stiffness is this guy. Alright, so an error was found earlier. Inter value is this. Oh, I think it's because of that comma. Doesn't recognize comma. Okay. Let's remove this comma. Alright. So then damping I don't put there. So for selecting the bodies, I have to come here first, select this guy, apply, and then for the other body, I'll come here, collect this one. Now you see that the spring connected this body, red body to blue body, okay? Next, I'm gonna do another spring that connects this blue body to ground. So come here, body to ground. First of all, the stiffness. Let me remove that comma again. So as I said, I'm gonna do same K for both. Then to connect the body, I'm gonna pick this guy, apply. So it's connected to ground now. So we have our system, right? So now we can try find our natural frequency. So we need to mesh it first. Generate mesh. Yeah, all right. Then right click here and then solve it, right? So we can solve it now. It's gonna give you natural frequencies. I forgot to actually tell to the software how many of them I need to find. So I need to do it here. So right now it's gonna find first 6. But let's say let's find first 20. Let's solve it again. Yeah, okay, so look at them. Right click here and you can pick all of them and then ask the software to find mode shape. So I'm going to create mode shape for all of them. And then we're going to see which one is actually the right one. By looking at the mode shape, we can figure out which one is the right one. Because some of them, as I said, some of them are like junks, rigid body motions. So let's do that. Find them. So let's look at them one by one. Some of them are going to be funny looking. This one, not the right one. Not the right one. Number 2, number 3. Yeah, see? These are definitely not right. If you go down, look at number 7. here is going to be number 6 actually. So look at this. This is again not related one. Let's go down. Number 9 or here number 8. Yeah, that's not again related. So the first one that we have, like, look at this number 11. Let me look at that one. Or number 10 here. That one is not related either. Okay, so let me close it. Number 11. Number 11 here. Let me see. Did we start from 0 now? So that was number 11. Number 12 is going to be here 11. Yeah, that one, that makes sense. Right? This is one of my mode shapes. Both of them are going up and down together. So look. That one is which one? Let me see. Let me erase this. So I'm just going to generate the twos that the numbers. Yeah, I want to generate these two only. Let's see what mode shapes are for those guys. Those are the, okay, so this one, yeah, this is the right one, right? This is one of them. That was 0.98421, okay, and then this one, yeah, this is another mode shape, right? All right, so let's see how they compare to our hand calculation, right? So if you remember, we said from the theory, we found one of them 1.618, 1.618 times radical k and divided by m. So if k divided by m is 100, radical will give it 10. So you're going to have what? 16. So you have 16.18 is the first natural frequency, or the bigger one actually. The other one is the smaller. So we should have called this one actually number 1. The other one is going to be 6.181. But these are in radian per second, by the way. But what you see in ANSYS is hertz. So let's find the first one, this guy. 6.181. This is radian per second. So divided by 2, divided by pi. So first natural frequency of this system is going to be 0.9837. So how much was here? 0.98421. If you refine the mesh, it's going to get closer. And the second one from here is 1.6. So let me divide this by 0.6181 multiplied by 1.618. This is going to be my second one, 2.575. So let me see how much he gave. 2.57. 2.575. Yeah, slightly off, but I'm sure if you refine the mesh, it's going to get better. So you see the mesh is like this. We come here, we can insert the mesh, sizing. Just say, click, select all, 2 faces. Element size, you see it's this. I'm going to make this smaller. So it's like, how about making it like 3 times as smaller almost. Now if I make the mesh and solve it again, let's see what happens. I'm sure it's going to get a lot closer to what you had from the theory, right? Close the calculator. Yeah, refine the mesh. It got slightly, yeah, see, a lot of smaller mesh. It's going to take longer. Right. All right, so let's look at them. 0.98364 2.5752. Yeah, I closed it by mistake, the calculator, so let's do it. So I'm just gonna check one of them. Let's check the bigger one, see how if it got closer. Yeah, we had here, let's see, 0.6, oh no, the bigger one is this guy, 1.618 times 10. This is in radian per second divided by 2 divided by pi. 2.575. 2.5752. Yeah, 2.5751 I have here. But it's got a lot. You know, you have more significant figure, right? For first one, I have to divide this by 1.618. Yeah, and then times 0.618. So 0.9835. 0.9835. You know, more significant figures, right? Alright, so the mode shapes. So again, the way you can identify the right natural frequency is you can, we know from our engineering, you know, we know from vibration course that how the natural frequencies are going to look like for a system like this, you know. This is one. The other one is this one, right? We're going opposite direction. So, it makes sense. Alright, so I hope you guys found this one, find it useful. Let's close this guy.